Okay, so we now come to our second talk by our very own Tim Suchanek, who will be talking about Prisma in React Server Components. So Tim probably needs no introduction, but I will do one anyways in case you're not familiar with some of his work. So Tim is a software engineer from Sauerland in Germany originally. He studied computer science at the University of at the Karlsrühe Institute of Technology, and he's passionate about startups and new ideas, which brought him to Berlin. And he's been with us at Prisma since 2016, where he leads the TypeScript efforts. So now I bring you Tim.
Hello.
Hello, sir. How's it going?
Hey, Daniel. Good.
So
a bit cold in Berlin, but it's good.
It's getting slightly, I mean, the days are getting longer, which is quite nice, I find.
That is true. Still a bit bright outside.
So last Christmas, you didn't give me your heart, but we had a lot of excitement around React server components, and now you're going to give us an introduction to how Prisma fits into that. Is that right?
Yes, correct. Yeah.
Okay, cool. So I'm going to share your screen, and the stage is yours.
Okay. Yeah, thanks, Daniel, for the introduction. Thanks for having me. And yeah, hello from Berlin. I'm Tim, and working as a TypeScript lead at Prisma. And so right before Christmas last year was the 22nd of December. There were news in the React ecosystem. Concretely, React server components have been announced. And today I will talk about how they're related to Prisma and why this is really exciting for the Prisma ecosystem to integrate into this. So we had this, So we had this tweet from Dan Abramov, 22nd of December, where he said, "How is this not illegal?" Where he had a SQL statement where he just had like select star from nodes, and then he was directly using that in a React component. And you might say, oh no, you cannot just use SQL directly in a React component. This looks so dangerous. You might be able to do SQL injections and so on. So Nico, our who is working in DevRel at Prisma, he directly posted this Drake meme and basically said, hey, you should not do SQL. You should instead do a Prisma query. And so we will now talk about today what does this even mean? How can you run SQL in React? Why does that even make sense? And what are these React server components about? So the first initial reaction that I saw from many people is, it's just PHP. And that is not the case. So why is it not just PHP? So if you hear the term server component, you might just think, okay, it's something rendered on the server, that's it. And that reminds many people of PHP or also other frameworks in which you are rendering server-side, like Ruby on Rails. So why is it not just that? There are two main points. So on the right side, we have these dots here. And let's say orange is the server components, blue are client components. So first of all, to define server components, we need to define what are the components called that we are writing today, the React components that we write today. They're called client components. With that, we mean they're shipped to the browser, to the client. And any library that you're importing there is completely shipped to the browser. Like, let's say I use a date library that has like 20, 50 kilobytes. Then I am always shipping that to the browser, although I might just want to like render a little date and date field. And so what is possible now with the React server components is that in the root, you can have a server component that's rendered on the server. We will later go a bit more into detail what that means. And the interesting part is now that a client component can be a child component of that. And again, a server component can be a child component of the client component. And so you basically can have this mixed tree. And you as a developer, you don't need to care. React just takes care. And so what is happening if I'm rendering a client component, and let's say I'm clicking on a button and I now want to render a server component, what is actually happening is that React does a request to the server component, React server component backend, and is rendering that markup in the server, sends that markup back to the browser, but no single JavaScript dependency is being sent back, but just a pure markup. Pure markup means, also here I can say that directly, that means we cannot do anything dynamic, and like a dynamic input with an event listener or something like that. That is not possible. In server components, however, we can do quite a lot, and you will realize in your applications maybe even a majority of the components can be server components. So that is one point. The other point is why this is not just PHP, is streaming the component back to the client. So what does that mean, and why is this interesting? Let's say we have a component that needs to fetch from some really slow API some data. And so what it can do, it can directly return already like a spinner or some skeleton or something like that. And in the meantime, fetch the data. And then once it's done, it will actually return the full rendered component. And this can be basically streamed to the client. Again, something that in this traditional PHP model you will not be able to do. We will later go a bit into this streaming protocol because it's quite fascinating. So why should we even do this? So the big trade-off that we have here is developer experience versus performance of our application. So the React team, they got a lot of feedback, and they had, I mean, in these many years of experience now, had a look at how can they maybe find a new trade-off between developer experience and performance. So performance, if you, for example, use GraphQL, but you don't have to use GraphQL, you can use a library called Relay. That is a very optimal performant library that helps you to fetch data in an optimal way, and maybe already pre-fetch data that it knows you need later. And you can use Relay. That also helps a lot with performance. But not everyone wants to use Relay, and it is, let's say, a bit opinionated. It forces you to use a certain architecture. If you want to use that architecture, it's good, but it is for sure there's a learning curve involved. And now the Facebook team is using Relay. Why are they then still interested in the server components? Another big point are dependencies that we don't want to ship. So if I have a date library, like date functions, for example, I think they're around 20 or 50 kilobytes minified. So if we use that library just to print one single date somewhere that we want to format, we in the traditional React model would have to ship all of that to the client. So we now added like 20, 50 kilobytes to our bundle, which makes our whole application slower. And last but not least, the big point of Relay is really to prevent request waterfalls or round trips. So what do I mean by that? I have a little example here with my limited design skills. I made this little mock-up here. So let's say we have an application with a list view and a detail view. And so what we would want to do is we want to first get the list view. Maybe the list view is even depending on some search query. And depending on what is the first post, that particular post we want to show in the detail view. So if we want to now fetch the data for that, we would first fetch the data for the list view. So we have run round trip. Let's say we're in a traditional React model. Yeah? We do a request from the client to the server. So we have this round trip. After that, the client now looks into the posts and says, the first post, I want to render that, and I need to detail information of that post now, because we not always want to fetch all the detailed information of all posts. Maybe we want to fetch the comments, for example. So we have another round trip to the server and get that detailed information for that post. So we have these two round trips, and that is basically the request waterfall. So you could even go levels deeper. Yeah? Again, if you would now in a third step, maybe even get the comments, it gets worse. So we're adding up all of these request times, which is not what we want. That is something Relay can make very efficient, for example. And this is exactly the problem that is being solved by server components. So, and by the way, regarding the streaming interface, the React team specified, they wrote a spec for how to stream this kind of data that you would get from rendering a server component, how to stream that to the front end. So it's not just where they are not just sending like HTML tags, they actually have a quite smart streaming interface. So this is how it looks like if you open the network tab in a React server component application. So we started again with this Drake meme, and it was just before Christmas. And a few weeks after that, at Prisma, we said, hey, this is a perfect opportunity. Because why? Because you can directly use Prisma from the front end. That has not been possible before. So we should look into this. So that's what we did. And so the official demo from the React team is called the Server Components Demo, where they have a note-taking app. We will have a look at that in a bit, where they really show exactly this wireframe also that I just showed to you, where on the left side you have the articles or the nodes, and on the right side you have this detail view, like a master detail view, basically. And so at Prisma, we were also a bit busy. We created a so-called React IO library. So in this server component paradigm, you kind of need to be able to access data. And in order to not need an await statement in your component, we will get into that in a bit, you need to create like a dedicated wrapper library for anything that is IO. So the React team, for example, created one for Postgres, and it's called React PG. Also for the file system, if you want to read something, React FS. And we created React Prisma. This is used to query data. In a bit, we will also get into how mutations work in this setup. So yeah, you can check out this demo. It's at github.com/prisma/server components demo. And so what was really awesome to see, in January, we had a stream where we showed this early prototype of this React IO package, and actually Dan Abramov and Lauren Tan, who have been working actively on this topic, they joined our stream and even answered questions, and that was really awesome to see. And we are now in contact with them and try to make sure that the React IO, that the React Prisma library is always up to date with the latest React server components. And also here, I just want to say, as we do here in the README, this is highly experimental. The timeline is roughly half a year or a year to get this into production earliest. So this is really an outlook into the future, and helps us to see the vision, to see how you will be able to use a Prisma client together with React server components. So again, why is this exciting for Prisma? Because you don't need any API layer between your server and your client anymore, because it merged into one, which is great for many, many use cases. That makes it easier to get started. Again, in the tweet that Dan Abramov did, he said, like, this is illegal. I cannot just do SQL directly in a component. And that is obviously a great opportunity for Prisma, because Prisma as a data layer, rather, instead of just a simple database low-level client, has a great opportunity to provide permission logic, privacy-aware features. Prisma is actually working on things there. And that means front-end developers can directly use Prisma without the need to learn GraphQL, for example. But we talked enough. Now it's time to actually demo. So Inception. I have this demo open here. So this project here that you can see is the server components demo from the React team. They used the React PG library in order to access the database. There's some database access involved in this demo. In our case, we replaced that with the Prisma library. So let me just check. We should have the demo open here. Yeah. So let's first have a look at the demo. So this is exactly the setup that I showed you in the wireframe. On the left side, we have the nodes. On the right side, we have a detail view here. So we can, for example, create a new node, and we can say it's called Hello Prisma Meetup. And we can say, we can even put some Unicode in here if we want to, blah, blah. And that's done. Perfect. And on the left-hand side, we can now filter if we want to. So yeah, that's the demo. Now the question, how does it work? So the entry point to this whole thing is a server component. It's not a client component. And this server component is called app. It gets passed in certain props. How these props exactly get in there, you can have a look at the demo. It's a bit more involved right now. So again, it's just a prototype. But basically, this is rendered on the server, and the server root is basically passing in these props. So you have like a shared state on the top, and then that can be used in these child components. So for example, we have a search text. The search text comes from the search field, for example. So how does the search field work? It does something called set location, and use location is something custom. Like you could basically say it's a kind of context that the client can set to communicate to the server. So let's just assume it's kind of set state. And we're able to set this here in the ordinary on-change listener of the search input. So this component here, and also, by the way, how do we distinguish between client and server components? A client component just has the convention.client.js, the server component.server.js, quite simple. So then the Webpack compiler, they have a custom Webpack plugin, will differentiate and will make sure that the server components only end up on the server. They will never be shipped to the client, and only the client components are shipped to the client. So again, the server component is the root of all of this. That's basically what we see here. And so how do things get updated now? So again, we're setting this location thing. There is some magic. Let's just assume this is solved if you would use this, let's say in Next.js or Gatsby, whatever, in the future. So this is the setup we have. The search text gets set properly, and now we can render actually the list. So the list view that we have here on the left side, this part here, how is that rendered? So here we now use Prisma. This was the example where they used Postgres directly with SQL, but here we use Prisma. And as you can see, as usual, you have the type safety. So we have this JSON query API, as you know it from the Prisma client, and can now basically query for the search text here and filter the nodes based on the search text, which is, by the way, always case insensitive. So if we, for example, say Prisma lowercase, then it will work. And so this looks like magic. How does this work? There's no await statement, nothing happening. So I try to give you a very quick explanation. The idea is that this code here, if it is not if it's not a resolved promise, throws. So this is throwing a promise, this code. React then basically catches that, waits until that promise has resolved, and goes back and actually renders the stuff here. Yeah. So that means line 21 is not even executed as long as this is not there yet. So yeah, that is basically how it works. A bit crazy. Some people are criticizing it and say you should just use await, but I don't think that this is something that will still be negotiated or changed. This is a conscious decision of how the React team made this happen. And this is basically called React IO, this kind of setup here where you have this magic API. It looks like, hey, how can this be without an await statement? And so where do we get this Prisma from? This Prisma comes from the package React Prisma, and that just wraps the Prisma client. You can, by the way, check this out on github.com/prisma/prisma. You will find the React Prisma package in there if you're interested in how the implementation looks like. It's a fairly thin wrapper just around the Prisma client. So, but now we're just doing queries here. How do mutations look like? So let's say I'm creating a post. Yeah. So again, we call this Untitled 2 and blah, blah, blah. How does this work? Now comes the really genius part. So again, the React team wants to make this performant. And instead of, like, how would you do this now in ordinary React client application? You would probably do a call against some JSON API, and then you would maybe like post against that API, and then you would get back some JSON, and then you render the component based on the JSON that you get back. And here it's different. In order to like make things even more efficient and not unnecessarily render like ship code again, like for example for the date library here to the front end, if we post, and this is the post call to /nodes, which by the way, that's the API server. It's implemented here. It's a simple Express application, tuned a little bit. They added some stuff on top. But if you do that, you directly get back not the JSON, but you get back the rendered post. So with that, they're directly saving the step of maybe also having to fetch other data, whatever. It's directly returning the markup, basically. That is the genius part here. So mutations, the idea is really that mutations are directly returning the rendered markup, and it will directly be rendered into the browser. So you don't even need to do, let's say, cache invalidation if you use Apollo client or whatever. It's just directly rendering the markup, so that's not at all a concern. So in this Express setup here, so we're here just calling the ordinary Prisma client API. And so in this case, we're both writing into a file system. So in this demo, they chose to write the data into Markdown. So you have like a little bit like a blogging experience with Markdown, but on the other hand, it's also saved into the database. And so how does this magic send response function work? This is the function that returns this rendered tree. So this function, again, sets this location. The location is basically kind of context or state that is shared between the client and the server. And they are actually rendering a whole React tree. Again, that is this streaming interface now here. So they're piping that into the output here and into the response. And with pipe, this is really allowing us to stream results. So what we could do in our mutation, we could be able to say we already send something back, maybe like a spinner or something again, and then we would later render the actual data once we're done. So yeah, that is basically how you can use Prisma Client today with React Server components. As you see, this is JavaScript. This is not yet TypeScript, so a lot of work still has to happen. This is a new territory for the React team because, as you can see with the client and the server.js, we are now getting into bundling territory, which was something that the React team didn't have to do before. So they are still figuring out how to do things, how to package things, are working together with the Next.js team and so on. But yeah, we're making sure that this React Prisma package is always up to date. and you can check it out today. So you can just go to, let me see, you can just go to Prisma, github.com/prisma/server components demo. Yeah, that's it from my side. Daniel, I cannot hear you.
I'm sorry about that. Yes, so I was wanted to say thank you again for the talk. That was insightful, and I think a good refresher on the current status since the last time that we've spoken about this. So we're open to questions. Please use this moment if you have any questions regarding Tim's talk. And I have an immediate question that came up while you were presenting, and I wanted to hear your thoughts on. So if you use server components, does that mean that you essentially need to maintain an open connection to the backend?
I think the connection, it's like still request response based. So if the client finds out I now need to render a new server component, it would basically do a request in that moment to the backend. So that's also really interesting in order to understand it a bit more, just checking out this nodes demo, opening the network tab. I had to do it myself, and then you just click around a bit and you see what requests are actually being performed. Yeah.
Okay, and then we already got a question. So DB polling.
I mean, I guess if you want to have DB pooling, I think nothing really changed. Let's say you are deploying this to Vercel or whatever, some serverless environment. It's the usual business. If you want to have DB pooling, you can put whatever PG bouncer or something in front of it.
Mm-hmm.
Yeah.
Okay, Ahmed asked, so the idea of server components is to get rid of the API layer. Isn't Blitz.js already doing that? Oh, that's a great one.
That's a great one. So yeah, about that, how does this actually fit into the ecosystem? I didn't mention it. So first of all, Blitz is on top of Next.js, and let's first talk about the Next.js a bit. Next has two nice properties, one called get server-side props and the other one get static props. So why do we need server components if we already have get server-side props? Get server-side props is just giving a component its initial props, but that component is still a full client component that can do interactive stuff like an event listener. And you're still shipping that whole component to the client. And that also counts for Blitz. Blitz is still shipping client components, and Blitz is still, like if you have this request waterfall situation, you will still have that with Blitz. You will easily run into that. So yes, it looks like there is no API, but actually Blitz is under the hood just doing HTTP requests. And I think with the server components, if you can use them, you are, let's say, a bit more prepared to not get into these performance pitfalls.
Cool. So if there's no more questions coming in, I'd like to thank you again, Tim, for the talk.
Yeah, thanks for having me.
See you soon.
See ya.